Hi, fifth graders. We're going to be using some examples from Ed's Pet World today to learn about division. Ed's Pet World is a pet store in Homewood, and it is a crazy wild place. If you've never been, you need to check it out. But we're going to use some situations. They're getting animals delivered all the time. In this case, they're getting 456 fish delivered, and we have 4 tanks to divide them into. So I'm going to take my dividend, the amount, and I can make my division table, someplace where I can keep my numbers organized. Let's even imagine that this box is the tank, and I'm trying to divide them into 4 different tanks, smaller tanks. So I'm taking them from here, dividing them into the 4 tanks. Well, I'm going to use my multiples of 4 because I could put 1 in each tank, and that would put only 4. I would only use up 4. I could put 10 in each tank, so I like to use my multiples of 10. 4 times 10, I'd be using 40 of them. That's not very many. I want to go higher. What's a higher estimate of how many I could put in each tank? Again, I like to use my multiples of 10 because it makes the number get so big so fast. 4 times 100, ooh, 400, I like that. Because it's very close to the total amount I want to use up. So if I put 100 fish in each tank, I would be able to take out 400 of those fish. Out here, I'm going to tell you how many I put in each tank to get rid of the 400, right? How many do I have left? I've got 56 fish left. I go back to my chart. Will any of this help me? Well, 4 times 10, if I put 10 in each of the 4 tanks, I use up 40. That's not too bad. I'm going to do that. This subtraction can be imagined. You can represent taking the fish out and putting them in the 4 groups. How many did I put in each of the 4 tanks to get that 40? 10. And how many fish do I have left in this tank? 16. Well, that should be a memory fact. 4 times 4 is 16, so I can know right on the money exactly how many to put in there in each of the tanks. 4 more fish will allow me to use up or divide up, give away. 16 more, and I have none left. So I'm finished. I now know how many are in each group. And if 100 were in each group, then 10 more, then 4 more. That's 114 in each group. You are going to notice that your labels are going to become more and more important as you're dividing, because you've got groups, you've got a dividend, you've got how many are in each group. And you'll also want to notice that all of these numbers inside here are representing the fish, right? You had some fish, got rid of some fish, had some fish left, got rid of some fish, had some fish left. So this label really can go for all of those numbers. And there's your tank. Another thing that's going to become more important to you are your multiples or your division facts, because that's the way you're going to estimate and get this done as quickly and efficiently as possible. Let's take another situation. This is one where there are 264 birds. 264 birds. And watch this trick. I write my label right when I write my how many is in my dividend. And then I put it into the table. If I don't do that, I find myself trying to squeeze it in there, and then it's messy and it's not as clear. How many, let's see, 8 cages. So in this case, I have a total amount and I know how many groups I have. What I don't know is how many are in each group. Similar to the last problem. I'm going to start using my multiples of 8. I know every time I have to put groups of 8 in each time, so I'm going to use my multiples of 8. Well, 8 times 1 is only 8, so that's way too few. How about 8 times 10? 8 times 10 is 80. Let's go a little higher. I don't want to go 8 times 100 because that's too big, so maybe I'll just go 8, multiply 8 times 20. 8 times 20 is 160. So 8 times 2 was just 16, right? But if it's 8 times 10 times greater than 2, which is 20, my product is also going to be 10 times greater, and that is a great way to get those numbers high as well. Well, that's not quite big enough. Let me multiply 8 groups of 30. If I put 30 in each of the 8 cages, how many would I use? Well, 8 times 3 is 24. That's a memory fact. But since one of these factors is 10 times greater, the final product will also be 10 times greater. And that's looking pretty close to my actual dividend, so I'm going to use that 30. If I put 30 birds in each cage, I will get rid of 240, or I will divide out. Getting rid of sounds so, I don't know, severe. Anyway, 4, 16, 4, 2. I've got 24 what's left? Birds. Remember, we are still talking about birds in here. This is our dividend. They were birds. They're always going to be birds. We just happen to be dividing them out. Okay, I got 24 left. That is a memory fact. I kind of don't even have to use my multiple chart over here to get ideas because I already know that 8 times 3 is 24. So if I put 3 more in each group, we use up 24 and I have nothing left, so I'm done. How many are in each group? I take 30 that were in each group, then 3 more that were in each group, bring them up here because that's where we'll be looking for the final answer. So 33 what? How would I label this number? In each cage, or birds in each cage. Don't skimp on your labels. I promise you, as the problems get more complex, you will be so, so glad that you labeled all your numbers from the beginning. So we should be recording these in your chart. If you haven't already, go back and write those. And then let's start from here, writing with me as we continue on. We're doing crickets, and there's a bunch of them. 1,287 crickets. Whoa. And there are 11 cages. Okay, so again, I want to, I didn't label. Oh, see, I would have had to squish it in. Been terrible. Miss Wessel needs to take her own advice, right? And what are these? These are habitats, actually. I don't even know if I said that. Habitats. Okay, here I go. I know I could put more than 1 times 11. Even 10 times 11 is 110. How about if I put 100 in each to start off with? What would that be? Now that's a nice number. That's a nice amount. 1,100. I like that. So that's where I'm going to start. I'm going to put 100 out here because that's eventually going to come up on the outside. I think of all this as the quotient landing here, and all of this is the dividend. Anyway, 100 in each of the habitats will use up 1,100. How many do I have left? Okay, here's my multiples. So 11 times 10, maybe. It's in the hundreds. We can always try that. 11 times 10 is 1. And I have 77 left. 77 what? Crickets. Remember, we're still talking about crickets. Keeping that in mind and understanding that will be super helpful, even when we get into fractions. You'll see. I have 77 left. I don't like how crooked that is. I have 77 left. I can put 7 more in each of the habitats, and I will use up all 77, and there I am. I'm finished. There's 100 in each habitat, 10 more, and 7 more. Add all those parts together, and let's bring it up onto the top. Use up a lot of room, don't we? 117 what? You should always be able to label or name what your numbers stand for when we're working in a word problem, which we are today. 117 in each habitat. All right, we got 2 more to do. Let's do these together. All right, the next one is 435 frogs in 5 aquariums. Look, I'm not going to forget this time. And I have 5 aquariums, and I'm just going to call them tanks because I'll remember what that is. All right, so we start the process again. I want to estimate around or about how many can I put into each tank. I know that 5 times, if I put 100 in each of them, that would be too high because that would be 500. I don't have 500 to put into tanks. So I know it's going to be lower than 100. And what would you maybe try next? My multiples of 5. Well, I know that 5 times 9 is 45. So maybe I'll go a little bit lower. Maybe 5 times 8 is 40. And I'm using that because I know that 5 times 80 is going to be 400. One of the factors was 10 times greater. Therefore, the final product is 10 times greater. A nice way to get a high estimate. So I'm going to put 80 in each of the cages or the tanks. So there's 80 in the tanks, and that will use up 400. And how many will I have left? I'll have 35. And what are those? They're still frogs, right? I'm just slowly dividing them out. And this is a memory fact for me now. I know that if I put 7 groups of 5, I will use up 35. So I can put 7 more in each of the cages or the tanks, and I will get rid of all 35. How many were in each tank? 87. And that will go right up there, 87. Okay, last one. We're going to do snakes in cages. All right, 936 snakes, 936. I'm not going to forget, I am labeling because I don't want to be confused later. Labels will help you not be confused later. And there's 24 cages. I'm going to begin using my multiples of 24 right away. I know that 24 times 10 is 240. I might go ahead and just try that since it's at least in the hundreds. Or maybe I'll double it. What if I doubled it? 480, I like that even better. 24 times not just 10, but 20. If one of my factors double, my product will also double. I like that better. So I'm gonna go all the way up. How many did I put in each of the cages? I can look back here and find out that it was 20. 3 tens take away 8 tens, I can't do it. So 9 tens becomes 8 tens because I gave a group away. 13 take away 8 is 5. And 8 take away 4 is 4. Now I know I'm not going to do 20 again. And I could go with 10, and I might just do that. See what I get. 240. So easy to subtract that. 216. So I might, let's see, 24 times 10 was 240. What would you do next? Maybe half of that. If 24 times 10 is 240, then 24 times 5. If one of the factors is half as much, then the product is half as much. That's kind of the other way to use. And here's my multiples of 24. And it's not a common factor to be using, so you might have to be creative. 120. So in order to do the 120, I put 5 more in each one. I have 96 left. 24, how many groups of 24 can I make if I have 96? That's my basic question. Well, I know, you might not know that, but think about what you do know. I'm comfortable knowing that 24 times 2 is 48. And then I'm wondering, that's about halfway, right? So I might then say, well, what if I double, not just 2 groups of 24, but twice as many groups of 24 will give me 48 and 48, which will give me 96, and that's perfect. Doubling a factor will also double the product. And I'm just having to work around with my multiples of 24 until I find one that either hits on it or just an estimate that's close. These are called partial quotients because we're getting part of the final answer. This took 4, and I have none left. So in a division problem, your final answer is called the quotient, but we have been estimating all the way along to find partial quotients, and that's a term you're going to want to be familiar with. Partial quotient, partial quotient, partial quotient, partial quotient. Put it all together, 20, 39, and I'm going to put it up here